In the last video, we created a postcode object based on the JSON data that was on GitHub. These are the Australian postcodes, and I stripped out the information I didn't want and created a postcode object that contains a variety of properties, including the postcode itself, where the postcode is, which state, the longitude, latitude, etc. So our next stage is to download that data so we can put it into our app and display it on the screen. To help with this, I have included some extensions and a database wrapper. Now the extensions are a variety of code that I've written just to help me out to simplify a lot of processes. I encourage you to download them from GitHub as well, and I think that'll just make life a lot easier. The wrapper, we're not going to use a lot of this, particularly not in this particular video, but what it does have is a template for a data manager. So our data manager asks for SQLite 3 to be imported. This just brings all of the code required to work with databases, but again, we're not working with that in this video. The data manager is a class, just like our postcode, and it contains properties and functions. The data manager will be a observable object. So this is a macro which allows the view, or encourages the view, I should say, to look at the data manager for any changes. So if the data manager, for instance, downloads data from the internet and changes some properties inside of the data manager, it'll automatically update on the screen. Now, this works generally as a background task, and we can't work in the background and the foreground at the same time. It's probably not a great way of describing it, to be honest, but essentially the downloading of data will work in the background, and we have to make a connection back to the foreground, which is the app itself. It's known as the main thread. We won't go into details about that, but essentially this will create a connection between a background task that's happening in the brain of the app and connect it to the front end to what you can see in the body of the view. So the first property is a database pointer, but again, don't worry about that. We also have a database file name, which we're not worried about. And what would be our SQL tables, again, we're skipping that. But what we will add at the top here will be a variable called postcodes. This postcodes variable will be an array of the postcode object. So when I'm finished downloading the postcodes, this is where I will be storing the postcodes so the view can display them. Simple as that. Now, we may not display them all directly from here. We may do some filtering, some searching, but this is where I'm storing them, at least temporarily, while the app is open. These two functions here will actually open a database and create the tables based on these queries, but again, we're not worried about those. What we will be doing in the initializer is running a function. You can see it's been recommended to us that we're going to fetch our postcodes, and we'll definitely be doing that, but not quite like that. So the initializer is the function that runs when we make a data manager. Now, in our postcode, we required information when we created a postcode. In our data manager, I don't require any information. I'm just going to run some functions. And eventually, I'm going to run a function called download postcodes. I'm not ready to call this function yet because I haven't made it yet. Let's move down and create the function called get postcodes. And I won't return the postcodes. I'm just going to work with the variables inside the function. So here I am able to call that function, this asynchronous function, and it will run in the background. Oop, I'll call it download, I better change it to get. There you go, get postcodes. So I can now get the postcodes. It won't do anything yet, but I can call that function. So that's the three parts here. This is where I'll be storing the postcodes. This is where I am asking for the postcodes to be downloaded. This is how to get the postcodes. So how, when, and where. Right, so the first stage is I need to say where the postcodes are located. Unfortunately, I still have this open, and I'm going to grab the link from Safari and store it inside my function. So my API is located at this particular link. Now I got to check that this API is correct. It may not be correct. I may have copied it wrong. I may have typed it silly and missed a slash in there. Anything is possible, so I got to check that it's correct. So I'm going to put a guard in because I don't want to continue unless this API is correct and is a hyperlink, a URL. So guard is like a bouncer at the door. It checks that the URL can equal a URL from a string, and that string being my API. So the guard at the door will stop there if it's not correct. And if it's not correct, I'm going to print a nice little message saying invalid URL, and I'm going to put my API link in there. So when it prints into the console, it'll actually say to me what is wrong and give me a nice little link for me to test. I'm going to put a semicolon in so I can write this on one line. Normally you could hit return. You'd need to return put multiple lines, but I'm going to do it on one line just for ease of reading. So if it's not a valid URL, print that it's not a valid URL, give me that feedback, and then return out of the function. I don't want to continue, stop there, exit the function. If I'm good to go, we're away and we're going to start our work of downloading the data. So I'm going to do a let data and response equal try and await a URL session .shared.data. And I want to stop there for a second because I've missed something, and it's because I haven't read what this particular method does. So URL session is an object. Like we've made our data manager and postcode, it is an object, and it contains a variety of functions which are referred to as methods. And this particular method called data requires a URL request. Well, I don't want that one because I don't have a URL request, but I do have a URL. Now this is an asynchronous function, which means it'll run in the background while the view is still working. So the user might be interacting with my app and postcodes are downloading. And this function will throw an error if something goes wrong. For instance, I don't have an internet connection. So I might be working on an iPad for this application and I'm not on Wi-Fi and I don't have cellular data. So rather than shutting down the app and having the app crash, I just want to throw an error. This function will return data, zeros and ones, our JSON data, and a URL response. Now the URL response is a variety of data, but we usually refer to them by their number. So you may have seen a 404 error, which means that the website doesn't exist. Now I'm going to use this function, but I'm going to cut it out first because I'm going to insert a do catch print error. Let me just explain that. So I'm going to try and do this method, this function, which is essentially go to Safari and access this URL and go get that data. So I'm going to try and do this function. Now, it may throw an error. As we saw earlier when we started typing data, we have throws an error. Well, that error is caught and printed on the screen if it occurs. So let's say again, hypothetically, on my iPad, I am trying to do this method and it throws an error and I catch it and print it on the screen. Well, in this case, inside the console. Now, it would be nice if we used a nice little alert that we could not access the data, etc. But we won't worry about that now. We'll keep it nice and simple. We'll just print this into the console so we can read that information. Now, the console is actually down here. I'm going to click the button and bring up my console, and I'm making sure that the right-hand side button is selected. Don't need the left as much, but I need the right, so I'm able to see in the console all of those nice errors that I'm going to get. Things like invalid URL or the error from downloading the data. So let's hypothetically now say it worked. So we're on our iPad and we do have Wi-Fi. I now need to check before converting the data that there is actually data there. So if I was heading over to here in GitHub, and let me just close that one, and let me just throw in, get rid of the R there. I end up with a 404 error, which is saying that I can't find this page. So GitHub is telling me this page doesn't exist. Now, even though it doesn't exist, I'm actually getting a page telling me it doesn't exist. And technically, this is data. That little image, the text down the bottom, that's all data. So if my app was accessing that hyperlink or that website, it would get data, but it would get a 404 error as well. Now, I can't convert this because it's not JSON. It's not in the right format. So I want to check that, yes, I'm getting data and it's not an error, not a 404 error or any other error I'm going to get. Our ideal scenario, we want something between 200 and 299. There are good responses. And if we get a successful response, I then want to convert all my JSON. So back to our app, I'm going to do a quick little check. If the response is successful, so there was a good response from the server and I got something between 200 and 299. Now this here is actually a extension of mine, which is a extension to URL response. And it just says to me, is it a good one or not? Yes or no. So this is why this works. Without the extensions, this will not work. Then, if the data is empty. Now, I don't want it when it's empty. I want it when it's not empty. And that's the exclamation point. We're asking for the opposite. So, is the data empty? Well, I want it when it's not empty. And then I can continue. Now, before I carry on, I will do some nice little printing into my console. So if there is a problem, I'm told inside the console. I'm preparing myself for something that might go wrong. So if the data is empty, so there was no data, print no data found at, and again, I'll put my API in. If the response is successful, well, no, I want to know if it's not successful. Now, I could do this another way. You've seen a little helper come up. I can check if the response is successful equals false, because this will return a true or false. But it's extra code, and I quite like just putting in not, so the opposite. So is it successful? Is it not successful? If it's not successful, print invalid response at, actually I might put the response.code. Now again, that's one of my extensions. So it'll put invalid response 404 into that little message at API. So I've got my error messages, and that's going to help me out if something goes wrong. So I did get a good response. The data is not empty. I have data. Well, let's go to my postcodes array and try and use the JSON decoder to decode an array of postcode from the data I downloaded. So it's going to use the same do. So I'm going to try and do the decoding function or method inside the JSON decoder. I'm going to try and do the decoding method inside of the JSON decoder, decoding an array of postcode from the data. Convert this data into an array of postcode. And I want to store that inside postcodes, which refers to this lovely array up here of postcode. Now, some errors you might get at this point. You might get an error that says it cannot be decoded. And that's generally because you didn't put the decodable protocol in. Just make sure now that you've got decodable, and why not identifiable at the same time. So that's done now. I've got my postcodes downloaded. They are inside my data manager. I have asked for the postcodes to be downloaded, and I've taught the postcodes how to be downloaded. I've taught the function, I've taught the data manager how to get them. And we're all done. Let's head over to the content view. Bring down our squiggly brackets because I like them lining up under each other so I can see a nice diagonal line in and diagonal line out. And I don't want this anymore. Actually, I won't change that yet. Let's go above the body. So above the body, but inside the struct, is what I refer to as the brain of the view. And I'm going to put my data manager inside the brain. I'm now going to get rid of this and just put in my list. And I'm going to do a loop through all my postcodes. For each data.postcodes. Now again, you might get an error at this point saying that it needs to be identified. Again, if you haven't got identifiable, you will need to put into here how to identify each one of these uniquely, which you would put something like this in and say that the ID is unique, but we don't need this because we made it identifiable. So for each postcode in my postcodes, let's make a VStack that aligns to the left leading, or at least in my context, in my English-driven app. I've got a VStack, and you can see my VStack has appeared there, but no information yet. Text, postcode, dot, postcode. And there's all the postcodes appearing. Text, postcode, dot, locality. Text, postcode, dot, state. There they all are. As we scroll through, that's every single postcode. Now I think what would be interesting would be to throw this in a VStack. Have a nice simple text at the top here and say, sure, just put as a plus, data.postcodes.count, and use the description of that count postcodes found. Here we are. So you start at 0. So initially it was 0. So if I change this a little bit, you'll see 0 just pop up for a second. And in that split instant, Swift ran the initializer, that's the initializer there, for the data manager, went and ran the function called getPostcodes. And that split instant, it took all that JSON data, converted into 18,559 postcodes, and made them available on the screen. And this is why we just love writing apps, because that speed and that simplicity is just amazing. In our next video, we'll look at filtering and searching this data. It's a nice little simple function that we're going to create, which will make our app more functional.